Hi grade 11s, I hope you're well. Today we're going to look at the sum of arithmetic sequences and look at sigma notation, and we're especially going to look at these two equations here. Sn is equal to n over 2, 2a plus n minus 1d, and then the other one that's not on the formula sheet. So let's have a look at that formula that's not on the formula sheet. So Sn is equal to n over 2a plus by L. So Sn, of course, is the sum of a certain number of terms. N is the number of terms in the sequence that you're finding the sum of. A, of course, is the first term, and then L is something we haven't experienced before, is the last term. So this is old legend that said there was, apparently it was Einstein, that he was given homework, or he had to set attention of some sort, and the teacher asked him to add the sum of the first 100 numbers, 100 natural numbers together. So 1 plus by 2 plus by 3 plus by 4 plus plus 96 plus 97 plus 98 plus 99 plus 100. And he got the answer apparently, within a couple of seconds. And so we're not sure if this is the real story, but anyway, it's a cool story. So let's go for it. So what he did is he added the first term and the last term together. So you had to get 1 plus 2 plus 3 plus 4 plus 5 plus 6, until 100. So he said, okay, so 1 plus 100, the first term plus the last term, okay, that's equal to 101. Okay. What is 2 plus by the second last term? So the second term plus by the second last term. 2 plus by 99, that is also equal to 101. And then the same story, what is 3 plus by third one plus by the third last one? 3 plus by 98, that's also equal to 101. Oh my gracious. And if you can just keep on going with this, 4 plus by 97, the fourth one plus the fourth last one, that's also equal to 101. So in other words, how many of those pairs will there be? There will of course be 50 pairs, right? So it will go up to 1 to 50, and then it's a double. So it's 50, in other words, times by 101. And what is 50 times by 101? Well, 50 times 100 is equal to 5,000, and 50 times by 1 is equal to 50. So therefore, that answer is going to be 50,050. How cool. So this formula actually just works on this principle. So in other words, it's the sum of the first and the last term, right? So the first term plus the last term, all right? And then it's the total number of terms divided by 2. Okay, so that's one formula that we can use. So in other words, if I ask you to find the sum of 1 plus by 3 plus by 5 plus plus so all the odd numbers, in other words, all the way up to 99. Okay, so all the odd numbers, so every other one up to 99. You would say that, well, that is going to be, we don't know how many numbers there are. Okay, so we first need to find out which, how many terms will give me 99, right? In other words, which term's value is equal to 99. So in other words, what's the general term of this baby going to be? Well, that's going to be a plus by n minus 1d, right? So in other words, it's going to be Tn is equal to a, which is equal to 1, plus by n minus 1. And what's the difference here? Well, it's 2. So Tn is equal to 1 plus by, and then you just expand that, right? So then that's going to equal to 2n minus 2. So therefore, the general term is equal to 2n minus 1. Okay, so now we know what, so we know the value of a term. So 99 is then equal to 2n minus 1. We want to know which term has got a value of 99. So therefore 2n is equal to 99 plus 1 is 100. So n is equal to 50. So in other words, this will be the 50th term, right? Will equal to 99. So in other words, if we want to find the sum of that sequence, the sum of 1 plus by 3 plus by 5 plus dot 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 plus 97 plus 99, okay, so what do we need? Well, we're going to find the sum of the first 50 terms. Remember, it's Sn is equal to n over 2, the first term plus the last term, so sum of the first 50 terms. So it's 50 divided by 2, n is 50, right? The first term, well, that is equal to 1, and then the last term, well, that is equal to 99. It's 99, and what is that equal to? The sum of the first 50 terms there is going to equal to 25. 1 plus 99 is 100, and what is 25 times 100 is 2,500. The default formula we normally use to find the sum of an arithmetic sequence is Sn is equal to n over 2, this baby, 2a plus n minus 1d. And you know this by now then. This is the sum, that's the sum, that's how many terms you're finding the sum, so how many, that says how many terms. A, of course, is the first term, the value of the first term. N, of course, is the number of terms. And then D is, of course, that common first difference. Right, cool. So let's have that same. Let's do the same problem using this formula now that we've just used. So in other words, we've got 1 plus by 3 plus by 5 plus by 7 plus dot 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 plus 97 plus by 99. So it's the sum of all the first 50 odd numbers. Okay, so we still need to work out this is equal to term 50. Term 50 is equal to 99. How do I find which term is equal to a certain value or the value of a certain term? Of course, the general term is very important there. Okay, so what do we have so far? We have the first term. Well, the first term is equal to 1. The common difference, we need the common difference. The common difference here is 2. Then what's quite cool, we need to know how many terms there are. So, well, you just work out which term has got a value of 99 there, and then you of course know how many terms there are in the sequence, and then you just square it. So therefore, it's the sum of 50 terms is equal to, so and then n over 2, right? So it's 50 divided by 2, then it is 2, a, and what is a equal to? A is equal to 1, plus by n minus 1, and n in this case again is 50, so it's 50 minus 1, times by that common first difference. So what is the common first difference? It is 2. So therefore, it is the sum of the first 50 terms, it's 25, 2 plus by 49 times by 2, right? Sum of the first 50 terms, 25, 49 times by 2 is equal to 98, so therefore we've got 2 plus by, that's it, 25, 2 plus by 98 times by 25, so the sum of the first 50 terms is 25 times by 100, and 25 times 100 is equal to 2,500. Okay, so in other words, we need a couple of these things. We either need the number of terms, we need the first term, and we need the difference, and then we can work out the sum. If I give you the sum, one of the other variables can be missing. In other words, the number of terms, and then I give you all the rest, or I can give you the number of terms then, but I don't give you the first term, all right, and I give you the difference. So, one of those variables can be missing. Okay, let's have a look at example 18 in your textbook. So what we've got here is we need to find the sum of the first 20 terms. So in other words, n is equal to 20. We're going to find the sum of the first 20 terms, right, of the sequence. And then in this case, so in other words, n is equal to 20. We need to know what is 20 is equal to. We know a is equal to minus 1, and we know the common first difference there. What is the common first difference? It's 4. You add 4 to every single term to get the next one. remember, if you don't know how to work that out, it's term 2 minus term 1. Those consecutive terms, of course, should be equal. In other words, term 3 minus term 2, that should be the same value, right? Okay, so let's go for it. So we've got Sn is equal to n over 2, 2a plus by n minus 1d. So in other words, we want to work out the sum of the first 20 terms. So S20 is equal to 20 divided by 2, and then it is 2 a, and a in this case is minus 1, plus, and then it is going to be 20 minus 1, and then multiply by the common difference, and the common difference here is equal to 4. Right, so the sum of the first 20 terms in this case is going to equal to 10, and then it's minus 2, and then it is going to be 20 minus 1 times by 4, which is equal to 76, I think. And so S of 20 is equal to 10, and minus 2 plus by 76 is equal to 74, and 74 times by 10 is equal to 740. That means the sum of the first 20 terms has got a value of 740. Right, so let's look at this one. So this is example 19 in your textbook. So 3 plus 5 plus 7 plus ... all the way, all those, every other number, all the way up to 111. So we've got two choices. Okay, yeah, two formulae we can use. The first thing is we've got a bit of an issue. We don't know how many terms there are. So how many terms? So that will be our first objective. Get how many terms there are. But we have the value of a term. We know one of the last term's value is equal to 111. In other words, if we can find n, then we know how many terms there are, right? So let's go for it. So we've got, if we want to find the general term, of course, that's the objective. We need to find the general term. The general term is going to be, so it's a plus by n minus 1d. So in other words, we've got Tn is equal to a is, in other words, in this case, 3 plus by n minus 1, and the common difference here would be 2. Alright, so Tn is equal to 3 plus by, and expand, so therefore it is going to be 2n minus 2, so therefore, it's going to be 2n plus by 1, yeah? So in other words, now we know the value of the term. We know 111 is the value of one of the terms. We want to know which term is that equal to. So you minus 1 on both sides, and then you divide by 2, so it's equal to 55, I mean. Term 55 is equal to 110. Right. So in other words, we need to find the sum of the first 55 terms. So I'm going to use both of those formulae, and you decide which one you want to use. Okay, so let's start with the one on the formula sheet, the one we just did. No, n over 2, 2a plus by n minus 1d. Alright? So in other words, here we've got the sum of the first 55 terms is equal to, again, 55 divided by 2. And then 2a, and a in this case is equal to 3, and plus by n minus 1, in other words, in this case, again, 55 minus 1, and the difference there is equal to, we see the difference is equal to 2. Okay, let's go for it. So sum of the first 55 terms, so it's 55 divided by 2, 6, and 54 times by 2 is equal to 108. So we've got the sum of the first 55 terms. 55 divided by 2, 6 plus 108 is equal to 114, right? Sum of the first 55 terms. The product of those two, of course, then, not of course, use your calculator. So that's 3135, 3135. If we use the other formula, Sn is equal to n over 2, a plus by l. Let's see. In this case, you still needed to know how many terms there are, but there's a couple of steps that you can skip here. So we need the sum of the first. Again, we need to use the general term to find out the sum of the first 55 terms. So sum of the first 55 is equal to 55 divided by 2, and then it's the sum of the first term. This first term there is equal to 3 there, and the last term is equal to 111. Right, so therefore it's the sum of the first 55 terms, and it is 55 over 2, and then 3 plus 11 is equal to 114. Then we have the exact same one, so we just got it upstairs there. So sum of the first, that's the sum of the first 55 terms, is then also equal to 3,135. Yay. So you choose which one you like most, and it doesn't matter. Just saying again, this one is on the grade 12 formula sheet. This one, for some reason, is not. Let's look at example 21 in your textbook here. So how this question is slightly different is I give you the sum, right? I give you the value of the sum, and I want to know how many terms, right? In other words, I don't know what n is, right? How many terms of arithmetic sequence will equal to that sum? Okay, so let's check what we've got. So in other words, we know that a in this case is 4, right? The first term is 4. We know the difference is equal to 3, right? 7 minus 4 is 3, 10 minus 7 is 3. We don't know what n is. We know what Sn is equal to. The sum of a certain number of terms is equal to 175. We just now need to find what n is. Okay, that doesn't seem too bad. Let's go for it. In this case, we don't have the value of the last term, so I wouldn't use that other equation, right? The a plus l. No, that's not necessary. So in other words, we're just going to use our default formula now. So Sn is equal to n over 2, 2a plus by n minus 1d. Okay, so it's Sn, right? The sum of a certain number of terms is equal to n over 2, and then it is 2. And a in this case is equal to 4, and then we've got plus by n minus 1, we don't know what n is, and then we've got the difference, the common first difference here is equal to 3. Right, but we know what the sum is. The sum is equal to 175, so 175 is equal to n over 2, then we've got 8, expand that, you've got 3 and minus 3, right? So in other words, 175 is equal to n over 2, and then 8 minus 3 is 5, so it's 5 plus by 3n. Alright, now I don't like fractions much, so I would just multiply 2 on both sides, and 2 times 175 is equal to 350 is equal to n 5 plus by 3n. You're right with that. Okay, so this happens quite a lot. And of course, you can already see what's going to happen here. If you're going to expand that, you're going to get 5n plus by 3n squared is equal to 350. And what do you have there? You've got a quadratic trinomial. Alright? So just rearrange it. And then you either solve this using the quadratic formula. I would advise this. Or factorize the living daylight out of this. Okay, and if you factorize, I'm going to skip that. You know how to use the quadratic formula. You're going to get n is equal to 10, or n is equal to minus 35 over 3 of some sort. Now, you want the positive integer, right? The natural number. In other words, the sum of the first 10 terms is going to equal to 175. Now, this just doesn't make sense, right? The sum of a negative number of terms is equal to 175. That's not really making sense. We want to know how many of those terms we should add together. Right, so you want to look for the natural number, positive integer, right? Okay, so the next thing I want us to explore is sigma. So sigma is what I just drew there. It's the Greek alphabet letter for S, and S of course means sum. So sigma is equal to none other than sum. Sum is equal to sigma Sigma is sum. If I ask you a sigma, I ask you to find the sum. Right, there's nothing strange about it. Okay. The only thing that might be confusing at first is, so when you write your sigma, right, there's a couple of elements to it. There's a number sometimes on the top there, or not sometimes, there's a number on the top, and we say this is the top counter, all right? And then there's a number on the bottom, and we say that's the bottom counter. I'll explain that now. Then right next to the sigma, we've got something in terms of a variable, and that is the general term, right? And that is equal to something. And that something, of course, means the sum. Yes, it's equal to the sum. Right. Now let me explain that quickly. So if I give you something like this, so sigma, the sigma of, say for example, k is equal to 1 to 7, and, well, let's just have something a bit easier for now, just to 3 of 2k minus 1, right, is equal to x, and ask you what is the value of x. Okay, so how this works is you're going to substitute the bottom counter. Okay, remember this is the bottom counter. You're going to substitute the value of that variable of the bottom counter into the general term, right, to generate the different terms. In other words, term 1, for term 1, we're going to, because you see this general term starts at 1. So for term 1, we're going to write down the general term, in other words, the 2k minus 1. And what are we going to do? We're going to substitute k is equal to 1 into there, right? Minus 1. Do you understand that? So where that bottom counter starts. So 2 times by 1 is 2, and 2 minus 1 is 1. All right? And for term 2, we're going to, it's a plus, of course, between them. For term 2, we're going to, so again, so it's 2k minus 1. We're going to substitute, what's the next integer then after 1? It will be 2, right? 2 times by 2 minus 1, so that is 4 minus 1, which is equal to 3, right? So what is the next one then? And then we keep on doing that until we reach the top counter, okay? So that is my max, right? We keep on counting from there to there. A lot of arrows. All right, so from there to there. So term 3 there is equal to then, it's going to equal to 2, well, the 2k minus 1 is 2 times by 3 minus 1, and 2 times by 3 minus 1 is equal to 5. You got this. This very fancy way of writing is just to say, what is 1 plus 3 plus by 5? Well, x then is going to equal to 9. I mean, 1 plus 3 plus 5 is 9. Right. Let's, hopefully you're still with me. Right. Let's have another couple of examples here. So, okay, so let's look at another one. So there's a sigma, and so for example, I tell you that j is equal to 5, and then we've got a top counter of, so for example, 15, and then we've got something like 4j minus 1, and say for example that is equal to x. We want to know the sum of that. Okay, so we're going to add a couple of terms together here. It's term 1, term 2, term 3, term and until the last term. Right, we'll talk about the last term now. Okay, so for the first 3 terms, so what would you substitute into j? So for the first term, you write down the general term, so 4j minus 1. And what goes into j? Well, the bottom counter, it starts at 5. So it's 4 times by 5, right? Minus 1. 4 times by 5 is 20, and 20 minus 1 is equal to, yes, well done, 19. All right? And then what do we have? So then we're going to get term 2. Term 2, you write down the general term again. So in other words, it is 4j minus 1. And what is j after 5 then? So you start, remember, you start at the bottom counter and you keep on adding integers, right? After 5 comes 6, and then comes 7, and then comes 8. Okay, so in other words, what's after 5? 6. right? And minus 1. 4 times by 6 is 24, and 24 minus 1 is 23. Right, hopefully you're still with me. For term 3, you do the same thing. You just keep on increasing it, right? So we started off with 5, right? We upped it by 1, add 1, 6. So what's the next one going to be? We're going to say it is going to be 4 times by, yes, well done, I heard you, 7, right? Minus 1. So, and 4 times by 7 minus 1 is equal to 28 minus 1, and that is equal to 27, right? 27. And so we keep on going until we've reached the top counter. Okay, but how many terms are there? Okay, so if you start at 5 and you go up to 15, how many terms are there? So you can count on your fingers. So it's 5, 6, 7, 8, 9, 10, 11, 12. How many terms are there? Right? Are there 10 terms? Are there 10 terms? Who of you says 10? Come, put up your hand. If you say there are 10 terms, put up your hand. There's not 10. No. It's 11 terms, right? Just count. 5, 6. I mean, you can't see my fingers if I count. That's a useless exercise. But anyway, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 11 terms. An easy way to find how many terms there are. So if you want to know how many terms, what you do is you take the top counter, okay? The top counter, the 15, minus the bottom counter, right? The 5. And what do I need to do then? I need to add 1 to it. Right, and then oh goodness, what did I do now? And then you add 1 to it. So then that is equal to 15 minus 5 is 10, 10 plus by 1 is 11. Why do I need to add 1 to it? Because if you're just going to subtract 15 and 5, you're finding the difference between the last term and the first term, but you're excluding either the first term or the last term. You want to know how many terms there are in total. Another way to look at that is to think how many rows are there in an Excel spreadsheet. So like if something would start at row 5 and it goes to like row 20, how many rows are there? So you do the same thing. Anyway, but top counter minus bottom counter, and then remember to add 1. So in other words, if term 1 would start at 5, term 2 would be at 6, term 3 would be 7, and so on. So then term 11, there's 11 terms of the sequence. In other words, what we're going to do then is we're going to say it's 4 times by, and then what's what will be substituted into there for that last one? It goes to 15, right? So 4j minus 1, 4 times by 15 minus 1. 4 times by 15 is equal to 60, and 60 minus 1 is going to equal to 59. Right, cool. So the value of the last term, of the 11th term, is going to be 59. Right, so that's our sequence. 19 plus 23 plus 27. The rest is quite easy. Okay, so we've actually covered quite a lot. Okay, so the first thing, let's just revise a bit. Let's just go over it. So what do I do? How do I get the first 3 terms? The most important is, if you don't know what to do, is get the first 3 terms. Right, from there in, it's actually quite easy. So the first term, you move 5 into j. For the next one, you're going to add the next one, 6, next integer. And then you're going to substitute 7. And so you go on, and until you've reached the top counter, the 15. 4 times by 15 minus 1. Right, how many terms in the sequence again? Remember top counter, the one on top, minus the bottom counter, plus 1. Right, so 15 minus 5 plus 1. Okay, in other words, what we're going to work out here is we're going to find the sum of the first 11 terms. Remember, n is equal to 11. So in other words, and what you can do now is you can just make a little table here. What you've got n is equal to 11, right? And what is the value of a equal to? A is equal to 19. The value of the first term is 19. What is the difference here? The difference is going to equal to 4, right? We keep on adding 4. You can also see from the general term, it's 4j minus 1. So that, so that difference is 4. And what else do we need? Oh, we need to know x. In other words, we want to find the sum of the first 11 terms. That's what we want. Okay, so sum of the first 11 terms is equal to then 11 divided by 2, and then 2a, and a in this case is 19, plus by n minus 1. In this case, again, we're using 19. 11, there's 11 terms in the sequence, 11 minus 1, right? And the common difference is equal to 4, right? So what we've got then is we've got the sum of the first 11 terms, 11 over 2, that's 38, so that's 11 minus 1 is 10, 10 times by 4 is 40, and then so the sum of the first 11 terms, 11 over 2 times by 78, and do you guys know what's 11 over 2 times by 78? Yeah, that's equal to 429. So in other words, what did we work out? We worked out the sum of the first 11 terms of this sequence is equal to 429. Recap quickly, couple of seconds. Okay, what do? Work out the values of the first 3 terms. That's the important part. Remember, you're adding. Sigma means sum, sigma means sum, sigma means sum. Beautiful. Okay, sigma means sum. Work out the values of the first 3 terms. If you have the value of the first 3 terms, you've got A and you've got D. How do I find n? Top counter minus bottom counter plus 1. Right. And then you just move it into one of the equations. Of course, you could have used the other equation as well. You could have used the sum of 11 terms, then is that n over 2 a plus by l. In other words, it's going to be 11 over 2, a is equal to 19, the last term is 59. So therefore it is 11 over 2, 19 plus by 59 is 78, and then that will also give us, of course, 429. It doesn't matter which equations that you use, just use one that you're most comfortable with. Okay, so if we would look at example 20 in your textbook or in those notes, so calculate the sum, sigma, of the bottom counter 2, top counter 100 of 7 minus 2m. Okay, so let's chat this through. So my first objective is I want to know the values of the first 3 terms. So I want to know what term 1 is, what term 2 is, and what term 3 is. Okay, so let's do that first. There's not much thinking involved there, right? I mean, you're just going to write down the general formula, 7 minus 2m. Therefore, 7 minus 2, and what is m equal to? What's the bottom counter? The bottom counter starts at 2. So 7 minus 2 times by 2 is 7 minus 4, and 7 minus 4 is equal to 3. Alright, then what we've got 7 minus 2m again, so 7, what is after 2? The next integer is going to be, there we're going to substitute a 3m, right? 7 minus 2 times by 3, 7 minus 6, in other words, is equal to 1. Yeah, let's keep on going. And then we've got 7 minus 2m again, 7 minus after 3 is 4, yeah, so it's 2 times by 4, and 7 minus 8 is equal to, minus 1. Right, and then this continues. Okay, so and then we have the value of the last term. You can work it out if you want to. So in other words, 7 times minus 2 times by, let's just write this down, 7 minus 2 times 100, 7 minus 200 is then equal to minus, minus 193, I think, right? Okay, so that's it. So we've got the values of the first 3 terms, okay? How many terms are there in the sequence, okay? How many terms are there? So n is going to equal to the top counter, 100, minus the bottom counter, 2. But remember, you don't want the difference between those, and so therefore you need to add 1 to include either the first one or the last term. And then 100 minus 2 plus by 1 is 98, plus by 1 is equal to 99. Right, so let's go for it. So it's the sum, so we know what n is now, n is equal to 99. We know what a is equal to 3, good. We know what d is, the difference. What's the difference here? You're going to keep subtracting 2. Ooh, the difference is 2. Alright, and we want to know what the sum, in other words, of the first 99 terms is going to equal to. Alright, and it doesn't matter which formula you use. So in other words, if I use, because I have the value of the last term, it's sometimes easiest to use this one, n over 2a plus by l. If you have the value of the last term, that's the one you've got. If you don't have the value of the last term, see if you can work it out. If you don't want to, just use the default one. Doesn't matter which one you use. So it's the sum of the first 99 terms, and that's going to equal to 99 divided by 2. 99 divided by 2. And it is a is in this case is equal to 3, so it's 3 plus by the last term. And what is the value of the last term there? It's equal to minus 193. Alright, so the sum of the first 99 terms, so it's 99 divided by 2, and that is minus 190, it looks like. That's a 99, eh? So sum of the first 99 terms then is going to equal to minus 9,405. Alright, hopefully this makes sense to you. I know this has been a very, very, very long video, but there's just so much to cover here. Okay, so the last example I'm going to look at and is, so one, we've done one without sigma earlier on like this, one where I give you the sum, so I give you the sum, I give you the general term, but I don't know, I ask you to find n, so I don't know how many terms there are. Okay, so let's go for it, step by step. So the first thing we want to work out the value of the first 3 terms. Right, so that's not too bad, right? First term is going to be 6 times by something minus 1. And then it's going to be 6 times by something minus 1, 6 times by something minus 1. So what is the something? We start by substituting. The bottom counter starts at 1. So we substitute 1 into there, right? And what is the next one after 1? 2. And then 3. That's not too bad. 6 minus 1, 6 times 1 minus 1 is 5. And then we're going to add 6 times by 2 minus 1. And that is going to equal to 11. And then we're going to go 6 times by 3 is 18 minus 1, so that's equal to 17. Alright, let's go for it. So in other words, what do I know from just doing this? I mean, that is not bad, eh? Not bad at all. I know that a is equal to 5. I know that the difference, so a is equal to 5, right? I know the difference is equal to 6. Good. Right, and we don't know what n is. Okay, it is still a secret, but I know what Sn is. Oh yes, I know. It is equal to 456. Right. Because we don't have the value of the last term, I won't use that formula with the a and l, right? This n over 2a plus by l. So just use the default. In other words, Sn is equal to n over 2a plus by n minus 1d. So let's go for it. So it's the sum of the first n terms. I don't know what n is. So n again, n over 2, 2a. Do we know what a is? Yes, a is equal to 5, right? Plus by n minus 1. I don't know what n is. And do we know what the difference is? Yes, the difference is equal to 6. All right. But we know what the sum is equal to. The sum is equal to 456. So in other words, 456 n over 2, that's 10 plus by and expand, so it's 6n minus 6, so 456 is equal to n over 2, and then 6n plus by 4, right? And then our times by 2 on both sides, so that is equal to 912, and 6n plus by 4, so 6n squared plus by 4n minus 912 is equal to 0. Then you're going to use the quadratic formula, right? Except if you know the factors of 912, go ahead and you're going to get n is equal to 12 or n is equal to like minus 38 over 3 or some sort. Alright, so the minus 38 over 3 is not going to work. You just write there, well, that's not valid, right? I mean, that can't be. So in other words, n is equal to 12. What does this mean? It means the sum of the first 12 terms of this particular sequence is going to give me a sum of 456. Okay, great. 11s, you're probably so hurtful of me now. But anyway, just hopefully this will help you. And okay, see you later.